Hello everyone, welcome to Learn Online. As we all know, today will be our 9th session on trigonometry. If you haven't watched our previous sessions, go back and watch all our sessions. The link for all the 8 sessions have been provided in the description below. In today's class, we'll be dealing with one of the most important applications of trigonometry. Yes, that is heights and distances. Now, what do we do in this topic of heights and distances? How do we use trigonometry? Here, we use trigonometric ratios to find out the height of an object or distance between any 2 points or distance between any 2 objects. So, before we start understanding how we use trigonometry in the topic of heights and distances, you'll have to understand a few terminologies. Which are those? To make that clear for you, I'll be giving you a particular scenario here. So, what is that? Let's say there's one point on a bridge and I'll name this point as A, and I'll observe any object or anything that I want from this point. So I'll call this as point of observation, meaning I'll be observing everything from this point. Now if I draw a line straight to this point, so a line drawn straight to this point is called as horizontal. Now let us say there's a balloon that is flying in the sky. There's a balloon here that is flying in the sky. Now I want to observe that balloon. From where do I observe? I'll observe from this point here. So if you have to look at the balloon that is flying in the sky, where do I need to look? I need to look up. So now I'll draw a line joining the balloon and the point of observation here. So if I join a line from the point of observation to the balloon, what do I call this? I call this as line of sight. Line of sight. So now, what can you define line of sight as? Line of sight is a straight line joining a point of observation and the object that you are observing. Now, if you look at this carefully, what is happening? There is an angle that is formed between line of sight and horizontal. Is the angle above the origin or below the origin? The angle here is above the origin. So I'll call it as angle of elevation. Angle of elevation. So now, how can you define the angle of elevation as? Angle of elevation is the angle that is formed between horizontal and line of sight, and which is above the horizontal. So now, the same point here, we'll be observing another object. Let's say there's a football that is fallen below the bridge here. Now, if I have to look at the football below the bridge, where do I need to look up? I need to look down. So now I'll join this line from my point of observation to the object. So what do I call this line? This line is nothing but line of sight. Line of sight here. Once again, there's another angle that is formed between line of sight and horizontal. I'll take this as alpha. Now, is this angle below the origin or above the origin? The angle here is below the origin. So what will I call this angle? I'll call this angle as angle of depression. Angle of depression. So now you people tell me how we can define angle of depression as. Angle of depression is the angle formed between the horizontal and the line of sight, but the angle is below the origin. These terminologies play a very important role in solving problems on heights and distances. Now, let us understand how we use trigonometry in the topic of heights and distances. For that, let me give you a small example. Now, let us consider a flagpole. There is a flagpole here, that is on the ground. So what happens is there is one person who ties a rope from a point. I'll call this point as A. I'll call the point at which the flag is on the ground as B, and the topmost point of the flag as C. Now a person ties a rope from A to C here, that is to the topmost portion of the flag. Let's say he has tied the rope at an angle of 60 degrees. And the distance between the foot of the pole and the point where he has tied the rope as 10 meters. This will be 10 meters. Now if I ask you what is the length of the flagpole or what is the height of the flagpole, how do you solve this? Look at this. I told you we'll be using trigonometric ratio here. So what is that we need to find out here? We need to find out the height. So what is height when compared to 60 degrees? With respect to this angle here, what is height? It is nothing but my opposite side here. This height is the opposite side. So I'll write it as opposite side. Now, which is the other value that we know? We know that the distance between the point and the flagpole is 10 meters. So what is this 10 meters with respect to 60 degrees? It is my adjacent side. So I'll consider this as a ratio, opposite by adjacent. Which is the ratio that is opposite by adjacent in trigonometry? It is tan theta. Tan theta is nothing but opposite by adjacent. Now we know the value of theta here. What is the value of theta? It is 60 degrees. So I'll write it as tan 60 degrees is equal to opposite. What is opposite? I don't know. I'm calling it as h divided by adjacent, which is my adjacent side. It is the length between or the distance between the point and the flagpole. That is 10 meters here. So we have got so much. We have only one unknown that we need to find out. What is the value of tan 60? We all know tan 60 is nothing but root 3. Now I'll take this 10 to the other side. So it will be 10 root 3. That will be equal to the height. So the height of my flagpole will be 10 root 3 meters. So this is how we use trigonometric ratio to find out the height or distance. Now from the same diagram, they can also ask you another question. What is that? They might ask you to find out the length of the rope here. The length of the rope that is tied from the farthermost point on the pole to the point A. So what will be the length here? So let us find out. So what is the length with respect to 60 degrees here? It's always the hypotenuse. So my length is hypotenuse. So which is the other side that we know? We know that 10 meters it is. 10 meters they have given. What is 10 meters with respect to 60 degrees? It is nothing but my adjacent side. So I'll take it as a ratio. I've written it as hypotenuse by adjacent. I can also write it as adjacent by hypotenuse. Now in trigonometry, which is the ratio that is concerned with adjacent by hypotenuse, it is nothing but cos theta. Cos theta is adjacent by hypotenuse. Now we know the value of theta here. What is theta? Theta is 60 degrees. So cos of 60 degrees will be equal to adjacent. We know adjacent is 10 meters divided by hypotenuse. Do we know the value of hypotenuse here? No. So we'll consider it as L. So if I cross multiply this, what is the value of cos 60? Cos 60 is 1 upon 2. Now if I take this L to the other side, L will go to the numerator. So into L, that will be equal to 10 meters. So now what will be the length of the rope that is tied from the point A to the flagpole? It will be 10 into 2, that is 20 meters, and that will be the length of the rope. So now I hope all these basics are clear to you. How we use trigonometric ratios to find height and distances. Now let us see different types of questions that can be asked from the same topic. Now let us see in how many different ways the same kind of questions can be asked. Now we had considered an flagpole. Now let us say there is an electric pole for now. There is an electric pole here that is on the ground once again. Now what happens is this electric pole has some fault here. So electrician has to repair it. So what will the electrician do? He'll put a ladder. Will he put the ladder to the topmost point on the electric pole? No. He'll put it somewhere to the 3/4 of the electric pole here. Let's say the entire electric pole here is of 5 meters. The length of the entire electric pole is 5 meters. And the electrician is putting a ladder 1.3 meters below the topmost point of the electric pole. Now, the ladder that he has put is making an angle of 45 degrees. Making an angle of 45 degrees with the ground here. Now, they'll ask you to find out the length of the ladder that he has put. Also, they can ask you to find out the distance at which he has put the ladder from the foot of the electric pole. So, we'll have to find out the distance as well as the length of the ladder. So, how do we go about this? Now, what the students generally tend to do is, they know that the length of the electric pole is 5 meters. So, they'll directly take what is length when compared to this angle, it is opposite. So, they'll take opposite side equal to 5 meters, which is wrong. Absolutely wrong. Why? Look at this ladder. Look at the triangle here. From where is it formed? It is formed from this point. If the entire length is 5 meters and this is 1.3 meters. So, let me consider this as A, this point as B, this point as C, and this point as D. So, length of the flagpole is AC, that is 5 meters. We need the length BC. How do we get BC? AC will be equal to AB plus BC. AB plus BC here. So, what will be the length? AC, we know that it is 5 meters. And we know that AB is 1.3 meters. Plus, we don't know the length of BC. So, what will be the length BC here? BC will be equal to 5 minus 1.3, that is 3.7 meters. Now, we should be using the length 3.7 meters and not 5 meters. So, this length here is 3.7 meters. So, now first let us try to find out the distance here. Distance of the ladder from the foot of the electric pole. So, what is the distance with respect to this 45 degrees? It is adjacent side. So, it is adjacent side. So, now which is the value that we know? We know the length till which they have put the ladder. What is it? It is 3.7 meters. What is it with respect to 45 degrees? It is opposite side. So, I will take it as opposite upon adjacent. Now, which is the trigonometric ratio that is opposite by adjacent? It is nothing but tan theta once again. So, what is the value of tan theta? We know that theta is 45 degrees. So, I will write it as tan of 45 degree will be equal to opposite. Opposite is 3.7 meters. 3.7 meters divided by adjacent. Adjacent side is D here. So, what is the value of tan 45? Tan 45 is 1. That will be equal to 3.7. Now, the D I will be taking it to the other side. So, into D. So, now what is the distance at which he has put the ladder from the foot? It is 3.7 meters. So, this will be my distance. Now, how do we find out the length of the ladder here? Length of the ladder. What is length with respect to 45 degrees? It is my hypotenuse. So, I will take it as hypotenuse. Which is the one that we know here? We know the value of opposite side, that is opposite of 45 degrees. So, I will consider this to be as opposite upon hypotenuse. Now, which is the ratio that deals with opposite by hypotenuse? It is nothing but sin theta. What is theta here? 45 degrees. So, sin of 45 degrees will be equal to opposite by adjacent. Which is my opposite side here? Opposite side is 3.7 meters. Divided by what will be my hypotenuse? Hypotenuse is the length of the ladder, that is L. So, now what is the value of sin 45? We know sin 45 is 1 upon root 2. Now, length going on to the other side, it will be into length, that will be equal to 3.7 meters. Now, what will be the length of the ladder here? Length will be 3.7 into root 2 meters, and this will be the length of the ladder. So, what did we observe from this problem? We need to be careful. Whenever they have given the length, we need to first see which is the height that we should consider. If we had considered it as 5 meters, the entire problem would have been wrong. So, we should be careful on which height to consider. So, we need to draw a diagram so that you can easily get to know which is the height that you need to consider, which is the angle that you need to consider, and what is the relation between the side and that angle. Now, whatever we have done with problems till now, as the angle above the horizontal, that is angle of elevation. Now, let us see a problem on angle of depression. How do we? So, let me take up this problem here. Let's say there's a building. The building is on the ground. So from 7 meters from the point on the building, so I'll consider this point as B. 7 meters away from this point, there's another point. Let's say that point to be as A. From this point, they're tying a wire to the topmost point of the building here. So now they're telling that this wire is making an angle of depression of 60 degrees at the place where it is tied to the building. So now, how do we represent this 60 degrees? Where do we represent? Generally what students do is, they represent this angle as 60 degrees. Is it right? No, this is absolutely wrong. Why is it wrong? What do we define angle of depression as? Angle of depression is nothing but the angle formed between the line of sight. This is line of sight and horizontal. Where is your horizontal here? We don't have an horizontal. So we need to consider an horizontal here. So once we consider this horizontal, this will be the angle of depression. The angle made between horizontal and line of sight below the horizontal is called as angle of depression. And we know that angle of depression is 60 degrees. Now, how do we solve this problem? If this is 60 degrees, by geometry we know that alternate angles are equal. Which is the alternate angle to 60 degrees here? This angle is alternate angle. So this will be 60 degrees as well. So from geometry, alternate angles are equal. So even this angle will be 60 degrees. Now we need to find. Now if they ask you to find the height of the building or length of the wire. Here. How do we find that? We know that height here. Height of the building is nothing but opposite side with respect to the 60 degrees. So it is opposite. So now what do we know? We know the distance between the foot of the building to the point where the wire is tied, and that is nothing but adjacent side with respect to 60 degrees. So it is adjacent. What is opposite over adjacent? It is nothing but tan theta. So we know that theta is nothing but 60 degrees because we are considering this angle here. So tan of 60 degrees will be equal to, opposite is nothing but the height divided by adjacent, that is 7 meters. So what is the value of tan 60? Tan 60 is nothing but √3, and that is equal to height upon 7 meters. 7 meters to the other side, it will become 7√3. So what will be the height of the building? It will be 7√3 meters. Now if they ask you how to find what is the length of the wire that is tied from the building to the point A. So how do you answer this? Now we need the length. So what is length with respect to 60 degrees? It is hypotenuse. So now what do we know? We know the adjacent side here. 67 meters is adjacent. So instead of taking hypotenuse over adjacent, I'll take adjacent over hypotenuse. Which is my adjacent side here? What is adjacent by hypotenuse? Adjacent by hypotenuse is nothing but cos theta. We know that theta is 60 degrees. So cos of 60 degrees will be adjacent, that is 7 meters divided by hypotenuse, that is length of the wire. I'll consider it as L. So what is cos 60 degrees? We all know cos 60 is 1/2. Now length to the other side, what will happen? Multiplication into L, that will be equal to 7 meters. Now what is the length of the wire that is tied? Length will be equal to 7 into 2, that is 14 meters. So what we need to keep in mind, angle of depression is always the angle made between the horizontal and the line of sight. Do not get confused and take this angle as angle of depression people. You'll have to always take the angle between the horizontal and line of sight. Now let me give you another example. Let's see how else the question can be twisted. This will be the most important example that I'll be giving you. So please concentrate people. So now let's say there's a tree. So there's a tree on the ground. So I'll consider the topmost point on the tree as A and the foot of the tree as B. Now if I tell you there's a person standing 10 meters away from the tree. So there is 10 meters away from the tree, there's another person standing. So I'll consider this point as C, and there is a person that is standing here. Now if I tell you that the person is looking at the topmost point on the tree, so he'll look through his eyes. So he'll be looking to the topmost point on the tree here. So I'll consider this point as D. Now if I tell you that the person is looking at the tree at an angle of elevation of 45 degrees. Angle of elevation of 45 degrees. Now if I ask you, find the length of the tree or the height of the tree here. What will be the height of the tree? Now when I tell you height of the tree, it is opposite side to my angle of elevation here. So what is my opposite side here? Is it AB? Most of the students take AB as the opposite side, and that is absolutely wrong. Why is it wrong? Look at it very carefully. Now I told you what is angle of elevation? The angle made between the line of sight. This is line of sight and horizontal. Where do we draw the horizontal to? We draw a straight line from the point where we observe all the things. That is point of observation. Which is my point of observation here? My point of observation here is D. So if we draw a straight line to this point, I'll consider this point as E. So which is my opposite side? This is my angle of elevation, that is 45 degrees. So which is the side opposite to this 45 degrees? It is AE and not AB. So AE is my opposite side. So opposite side upon. Now whenever they have given a question like this, they would have mentioned you the height of the person. In this case, I'll tell you that the height of the person is 1.6 meters. This will be the height of the person. Now opposite. We need to find out the length of the tree. Length of the tree is opposite with respect to this 45 degrees. So which is the other thing that we know? We know that the person is standing 10 meters away from the tree. So even DE will also be 10 meters. So that is nothing but adjacent side. What is opposite over adjacent? We know that opposite over adjacent is tan theta. We know the value of theta is 45 degrees. So tan 45 degrees will be equal to opposite side, that is nothing but AE, divided by adjacent side. Adjacent side is 10 meters. What is the value of tan 45? Tan 45 is nothing but 1, and that is equal to AE by 10. 10 if I take to the other side, this will become into 10. That will be equal to AE. So AE will be equal to 10 meters. Now, is this the length of my tree? No, AE is not the length of my tree. My length of the tree is AB. So how do we find out AB? AB will be equal to AE plus BE. So what is the value of BE? We know that we have taken a straight line here. So BE will also be equal to 1.6 meters. So what is AE? AE we have found out it as 10 meters plus. What is BE? BE is 1.6 meters. So now what will be the height of my tree here? The height of my tree H, that is AB, will be equal to 10 plus 1.6, that is 11.6 meters. I hope every example that I have given to you is very clear. Once you are done understanding these problems, let us see our previous year questions. All the questions that we will be looking from now on will be our previous year questions that are asked in our SSC papers. So now let us look at our first question. So what does it say? They're telling 129 meters from a foot of a cliff on a level ground. The angle of elevation of the top of the cliff is 30 degrees. The height of the cliff is. They're asking us to find the height of the cliff. So one of the most important thing we have to know when you're solving problems on heights and distances is that you will have to convert your question into diagram. So In the diagram, what are they talking about? They're talking about the cliff. So in the question, they're talking about the cliff, meaning a mountain. So I'll consider the topmost point of the mountain as A and the bottommost point of the mountain as B. So this will be AB. Now they're telling 129 meters from the bottom of the cliff. So I'll take 129 meters. From this point, I'll call this point as C here. So from this point, it is making an angle of elevation of 30 degrees. So this point to the topmost point on the cliff, the angle of elevation here is 30 degrees. So now, what are they asking us to find? They're asking us to find the height of the cliff here. So, how do we solve this problem? We need to find AB here. What is AB with respect to this 30 degrees? It is my opposite side. It's my opposite side. So, what is the side that I know? What is the length that I know? I know BC. What is BC? 129 meters. So, that is nothing but adjacent side with respect to this 30 degrees. So, it will be adjacent. Which is the ratio that deals with opposite over adjacent? That is nothing but tan theta. Tan theta is opposite by adjacent. So, the value of theta here is 30 degrees. Tan 30 degree will be equal to opposite. What is the opposite? We don't know. We'll consider it as h upon adjacent side. Which is the adjacent side here? Adjacent side here is 129 meters. So, this is 129 meters. We all know that tan 30 degrees is 1 upon root 3. And that is equal to h by 129. So, what will be height here? H will be equal to 129 by root 3 and that will be our final answer. Now, do we have that in our options here? No, we don't have 129 by root 3 in our options. So, what do we need to do? Everywhere you look at the options, you have root 3 at the top. So, what we need to do here is, we need to rationalize the denominator. So, how do we rationalize the denominator? We know that we have to multiply and divide it by root 3. So, if you multiply and divide it by root 3, what do we get? Height will be equal to 129 root 3, the whole divided by root 3 into root 3. What is root 3 into root 3? Root 3 into root 3 gives me 3. So, if I simplify this, what do I get? 3 1 times, 3 4 times is 12, 3 3 times is 9. So, what will be my height? My height will be 43 root 3 meters and this will be the height of the cliff. Let us look at our next question here. What are they telling? A 1.6 meter tall observer is 45 meters away from a tower. The angle of elevation from his eye to the top of the tower is 45 degrees. Then the height of the tower in meters. As I told you, first thing we need to do is convert the question into the diagram so that it becomes very easy for us to solve the problem. So they're talking about a 1.6 meter tall observer. So there is a man who is 1.6 meters tall. So his height here is 1.6 meters. He is 45 meters away from the tower. So the distance of this man, I'll consider this point as A and he is 45 meters away from the tower. So I'll consider one tower here. So I'll consider this to be my tower. So I'll consider this point as B. And distance between A and B is 45 meters. Now what are they telling? The angle of elevation from the eye to the top of the tower is 45 degree. From this person's eye to the top of the tower. I'll consider this top of the tower as C. This point eye of the observer as D. And the angle of elevation is 45 degree. I told you clearly that the angle of elevation is nothing but the angle between line of sight. This is my line of sight and horizontal. So this will be my horizontal here. So this angle here is 45 degree. Now they are asking us to find the length of the tower. So how do we find the length of the tower? First we'll find the length from C to, I'll consider this point as E here. So first let us calculate the CE, then let us add BE to that. So that we'll get BC, that is nothing but the length of the tower. So how to solve this? What is CE with respect to 45 degrees? It is nothing but my opposite side. Now what else do we know from the question? We know that adjacent side, this is 45 meters. Because we have drawn a straight line here, this will also be 45 meters. So this will be 45 meters. That is nothing but, what is 45 meters with respect to 45 degrees? Adjacent side. So I can also write this as adjacent side. What is opposite by adjacent? It is nothing but my tan theta once again. So what is the value of tan theta? Tan of 45 will be equal to opposite, that is CE, divided by adjacent, that is 45 meters. Now what is the value of tan 45? Tan 45 is 1. So what is the value of my, what will happen if my 45 meters come to the other side? It will be multiplication of 45, and that will be equal to CE. So my length CE will be equal to 45 meters. So now what do we need to find out? We need to find the length of the tower. So what is the length of the tower? Length of the tower is CE plus BE, or it can also be called as BC. BC is equal to CE plus BE. We know that CE is 45 meters. So BC will be equal to 45 meters plus BE. BE is nothing but 1.6 meters, because we have drawn a straight line from the eye of the observer, that is 1.6 meters. So what will be the total value of BC? BC will be 46.6 meters. So this will be the length of my tower here. So do we have this in our options there? What is my first option? The first option is 55.6 meters. So we don't have this 46.6 meters in our options. So which will be my right answer? Right answer will be option D, that is none. Now let us look at the next question here. What does it say? A car traveling on a straight road leading to a tower from a point at a distance of 500 meters from the tower. As seen by the driver, the angle of elevation of the top of the tower is 30 degrees. After driving towards the tower for 10 seconds, the angle of elevation of the top of the tower is seen by the driver is found to be 60 degrees. Now they are asking us to find the speed of the car. Here, have they given us the height of the driver, or have they given us the height of the car? No. So what do we need to do? First, let us convert it into a figure. They are telling there's a tower here. So let me first draw a tower. So forgive me for my drawing here. So this is a tower. So I'll consider the topmost point as A and the bottom point as B. Point B is on the ground here. So this will be my point B. Now they're telling that the car is traveling from a point at a distance of 500 meters. So there is another point which is nothing but C, and this is 500 meters away from the tower, meaning the distance between this point and the foot of the tower is 500 meters. So from this point, the angle of elevation to the top of the tower is 30 degrees. So this will be the angle of elevation, and they've told that it is 30 degrees. Now, what they're telling, the driver after traveling towards the tower for 10 seconds. So he's traveled for 10 seconds and he has reached another point. I'll call this point as T. So from this point, the angle of elevation to the top of the tower is 60 degrees. It is nothing but 60 degrees. Now what are they asking? They're asking us to find the speed of the car. This is slightly a twisted question. Students might think that it is difficult, but then it is very easy, people. What do we need to find? We need to find the speed of the car, that is S. What is the formula for speed? Speed is equal to distance traveled by time taken. Now we know the time here. We don't know the speed. That is what we need to find out. So now, do we know the distance? No. What is the distance that's traveled by the car? First, the car was at the point C. Now the car has traveled to point D. So we need to find this distance here. I'll call this as D1. So this is the distance that we need to find out. So how do we find out? First, let me take up this triangle, triangle ACB. So first I'll consider the triangle. In triangle ACB. So what do we know? We know the value of BC. BC is nothing but 500 meters. And we know the angle of elevation, that is theta, is 30 degree. Now, what do we need to find out from this triangle? We'll find out the value of the height of the tower, that is AB. What is AB with respect to 30 degrees? It is nothing but my opposite side here. So it is opposite. What is that we know? We know the length of BC, that is nothing but, what is BC with respect to 30 degrees? It is adjacent side. So what is opposite by adjacent? Opposite by adjacent is nothing but tan theta. So what is the value of theta? We know that theta is 30 degrees. So tan 30 degree will be equal to opposite, that is AB, divided by adjacent, that is 500 meters. So what is tan 30? Tan 30 is 1 upon root 3. That is equal to AB by 500. If I take my 500 to the other side, it will become into 500. And that will be my AB. That is nothing but the length of my tower here. Now I know the length of my tower as 500 by root 3 meters. Now what I do is, I'll consider the second triangle, which is ADB. Now I'll solve for that. In triangle ADB, what is happening? What do we know? From this triangle, we know that the height of the tower, that is AB, that is 500 by root 3 meters. So AB is 500 by root 3 meters. So what else do we know? We know the value of theta or angle of elevation. In this case, I'll consider it as alpha, that is 60 degrees. Now, what is this? What is this thing that we need to find out? We need to find out BD. So what will be BD? BD with respect to 60 degrees is nothing but adjacent side. So adjacent side. What is the thing that we know? We know the value of AB. Value of AB is nothing but opposite side with respect to 60 degrees. So opposite by adjacent. Once again, what is opposite by adjacent? It is tan alpha in this case, because we are considering it as alpha. So what is the value of tan alpha? It is tan 60 degrees. That is equal to, what is my opposite side here? Opposite side here is AB, that is 500 upon root 3 into 1 by adjacent. Opposite by adjacent can also be written as opposite into 1 by adjacent. So what is my adjacent side here? We don't know. That's what we need to find out. So it is BD. So what is tan 60? Tan 60 is nothing but root 3 meters. Oh, sorry, root 3. Tan 60 is root 3. And that is equal to 500 by root 3 into BD. If I take BD to the other side, it will become into BD. Now, what will be the value of BD? BD will be equal to 500 by root 3 into root 3, because this root 3 will be coming down. So what will be the value of BD here? Value of BD is root 3 into root 3. That is nothing but 500 by 3 meters. Now what do we need to find out? We need to find out the distance D1 here. First we need to find out the distance D1. What is the distance here? Distance is nothing but, distance is CD. So how do we get CD? BC minus BD gives me CD. So CD will be equal to BC minus BD. So CD will be equal to, what is the value of BC? We know that BC is 500 meters minus BD. What is BD? 500 by 3 meters. So what will be the value of CD? CD will be, if I take the LCM, it will be 1500 minus 500 by 3. That is nothing but 1000 by 3 meters. And that will be my distance here. So the total distance d1 will be equal to 1000 by 3 meters. What do we need to find out? We need to find out the speed of the car. So how do we find out the speed? Speed will be equal to distance traveled by time taken. We know that the car traveled for 10 seconds here. So what will be my speed? Speed will be equal to distance, that is CD, that is 1000 by 3 meters. 1000 by 3 meters into time is nothing but 1 by 3. So time is nothing but 1 by 10. That gives me 100 by 3. So this is speed will be 100 by 3 meters per second. But do we have the same in our options? No. Every option that we have is in kilometer per hour. So what do we need to do? We need to convert this meters per second into kilometer per hour. So how do we do that? From our time, speed and distance videos, you'll all be knowing that conversion of meters per second into kilometers per hour is done by multiplying by 18 by 5. So it is 100 by 3 into 18 by 5. So 3 1 times, 3 6 times, 5 1 times, 5 2 times. So what will be my speed? Speed will be equal to 6 into 20, that is 120 kilometer per hour. Am I clear, people? The previous question that we solved seemed to be a little lengthy. But then if you start solving without explaining, you can solve that within 1 minute. All you need to do is, you need to know the basics properly. So now let us move on to the next question. What does it say? A kite is flying at a height of 75 meters from the ground. Now let me directly convert the question into a diagram instead of reading it once and then converting. So there is a kite that is flying in the sky. So it is flying at the height of 75 meters from the ground. So this length here is nothing but 75 meters. Now what they are telling, the string makes an angle of theta with the level of ground. So the string will be tied to the kite. So this is how we fly the kite. So this is making an angle of theta with the ground. This is nothing but my ground level. This is theta. This is my string. So now what they are telling, where cot theta is 8 by 15. Cot theta is 8 by 15. Now if I consider this point on the kite as A, the point where it is at 75 meters, the point on the ground as B, and the point from where that I am flying the kite as C. So if that is A, B, C, what is cot theta? We know that cot theta is nothing but adjacent by adjacent by opposite. So if this is theta, which is the adjacent side? Adjacent side is BC. So BC will be equal to 8 meters. So what will be opposite side? Adjacent by opposite. Opposite is 15 meters. So which is my opposite side here? Opposite side to theta is nothing but 15. So this is 15. The ratio is 15 upon 8. So now what they're telling? They're telling us to find out the length of the string here. So look at this. They've given the ratio as 15 and the actual value as 75. How do we get a ratio? How do we convert a ratio into actual value? By multiplying it with its HCF. So which is what will be the HCF here? I'll consider my HCF as X. So the ratio is 15. 15x will be the actual value and that will be equal to 75. So now what will be the value of X here? X will be equal to 75 by 15. That is nothing but 5 meters. So X is 5 meters. If X is 5 meters, what is the actual distance between BC? Actual distance between BC will be 8x. That is nothing but 8 into 5. So my value of BC will be equal to 8 into 5, that is 40 meters. So here it will be 40 meters. Now they're asking us to find the value of AC. What is AC? We know that AC is the hypotenuse. Now we'll be using Pythagoras theorem here. According to Pythagoras theorem, what is hypotenuse square? Hypotenuse square will be equal to sum of the other two squares, that is 75 square plus 40 square. But this looks a little complicated. So what can we do? We can also do it in another way. We'll take the ratio here, 8 and 15. We'll find out AC in terms of the ratio. So how can I write my AC square as? AC square can also be written as 8 square plus 15 square. So what is AC square? It will be 8 square, that is 64, plus 15 square, that is 225. What is 225 plus 64? 225 plus 60 gives me 285. 285 plus 4 gives me 289. AC square is 289. What will be AC? AC will be equal to root of 289. So what is root of 289? Root of 289 is 17. So this string here is 17. The ratio is 17. So what will be the actual length? Actual length will be, AC will be 17x. And we have found out the value of x as 5 meters. So AC will be equal to 17 into 5. What is 17 into 5? 50 plus 35, that is 85 meters. So the length of my string will be what? It will be 85 meters. Do we have that in our options? Yes. Option A, 85 meters will be my final answer. Let us look at our last question for the day. What does it say? A person of height 6 feet. There is one person who is 6 feet tall. So the length is given in terms of feet here. Now what is happening? He wants to pluck a fruit which is 26 by 3 feet high tree. There is one tree here. And the fruit is at the top. And the fruit is at 26 by 3 feet. So now, what is happening here? If a person is standing 8 by root 3 feet, so the distance between the person and the tree here is 8 by root 3. Now I'll consider this point here, where the fruit is as point A. The point at the bottom of the tree is point B, and this point is point C. Now they're asking, he wants to throw a stone, and they're asking at what angle he should throw the stone so that it hits the fruit. So whenever he's throwing this stone or whatever it is, we have to consider from the eye line here. That is, this will be my angle of elevation. So according to the definition, what is my angle of elevation? Angle of elevation is the angle between the line of sight and my horizontal. So this will be my horizontal here. So now I'll consider this point here as point E and this point as point D. Now from the triangle, in triangle ADE, what do we know? We know DE, the value DE. What is DE? It is parallel. We have drawn a straight line, so it is also equal to 6 feet. I'm sorry, it is also equal to 8 by root 3. DE is 8 by root 3. Now, what else do we know? We know that the total height of the tree is 26 by 3. So, total height is nothing but AB. AB is equal to 26 by 3. But in this triangle, what is there? We have AE and not AB. So, how do we find out AE? AB will be equal to AE plus BE. We know that BE is nothing but, we know that BE, point BE is 6 feet. So, AB is 26 by 3 feet. That will be equal to AE, which we don't know. We need to find that out. That will be equal, that will be plus BE. BE is 6 feet. So, now what will be the value of AE? AE will be equal to 26 by 3 minus 6 feet. So, AE will be equal to 63 is 18 and this is 26. 18 to 26, that's nothing but 8. 8 by 3 will be equal to AE. So, if AE is 8 by 3, then we know AE, comma, AE is. Now they're asking us to find the angle of inclination, that is nothing but theta. So what is AE with respect to theta here? AE is opposite, divided by. What is DE with respect to theta? DE is adjacent. What is opposite by adjacent? Opposite by adjacent is tan theta. So now tan theta will be equal to opposite. Which is opposite? AE. Opposite is AE, that is nothing but 8 by 3 divided by adjacent. What is adjacent side here? Adjacent side here is DE. What is the value of DE? Value of DE is 8 by root 3. So it will be divided by 8 by root 3. Now what happens? 8 and 8 gets cancelled. So this root 3 it will go to the numerator. So it will become root 3 divided by 3. So what is root 3 divided by 3? Root 3 divided by 3 can also be written as 1 by root 3. So for what value of theta do we get tan theta as 1 by root 3? Tan of 30 degrees is equal to 1 by root 3. So what is the value of theta here? At what angle should he throw the stone? He should throw the stone at an angle of 30 degrees. So do we have that in our options? Yes. Option B, 30 degrees will be my final answer.